Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7A in the great state of Texas, and we are using item number 46 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this graph of a quadratic function. We are looking for the equation that best represents this axis of symmetry. Now, if we look on our mathematics chart or reference materials, we will see the axis of symmetry has a equation for us, and then it's negative b over 2a. Doesn't really help us, right, if we don't necessarily have an equation. So that's the only thing that we are going to see on the reference materials. So we can't usually use that unless we have, like I said, the actual equation. And so let's just kind of move past that and let's visually see what do we know about this graph. So, well, we know that we've got some intercepts here. So let's talk about those intercepts real quick. So the y-intercept is where it crosses, the graph crosses this y-axis, and that's going to be at 4. Technically, it's 0, 4 if you wanted to graph it, but we know that the x value of any y-intercept has to be 0. Looks like our two x-intercepts are going to be fractions, so we're just going to kind of guesstimate them. As looks like I've got negative 1.5, and then it looks like it's a 5.5. Wanted to get technical, I would need to go ahead and find the equation and calculate the zeros manually. Remember, these x-intercepts can be called zeros. They can also be called solutions. All three terms refer to the same thing. Now, the only other thing we know, and now we're going to get closer to finding this axis of symmetry, is the vertex. This vertex we see right here actually does have a coordinate pair that we need to graph. So that's going to be x value of 2, y value of 6. Since it's a downward facing, that means this is our maximum value. So the maximum value of this graph is going to be that y value of the vertex. It's going to be 6. If it were an upward facing parabola, it would be the minimum value would be at that vertex. Okay? Now, that vertex is going to be very helpful because when we're thinking of symmetrical, we're thinking of two shapes that are congruent or two halves of a shape that are congruent. And the only way to cut this parabola and make it congruent is to find a line that splits it exactly in half so that each side is like a mirror reflection. And it is going to be right here, right where I drew that arrow. The axis of symmetry cuts right through the vertex. And actually, since it is a parabola that is facing down, rather than one that's like facing side to side, we need that x value. The x value of that vertex 2 is going to be our clue as to what our axis of symmetry is. Because this line that I drew right here, you notice that no matter what the y value is, it doesn't really matter, my x is going to equal 2. So that is going to be our equation, which does equal this, right, this negative b2 over a, whatever that is. But it's going to be that x equals 2, and so we could have immediately gotten rid of f and h if we wanted to because it's y equals. You're not going to get y equals 6 is this right here. Y equals 4 is this right here. Those are not symmetrical lines. And then x equals 0 is this x-axis. That doesn't work. So my answer here is G.